Okay, to find the area of quadrilaterals. Well, rectangles you already know, right? So here's a rectangle. Sorry for my bad drawing. And we're going to kind of change length and width, which is what you did in elementary school, and we're going to turn this into base and height. So the area of a rectangle, and this is something you already know, is base times height. Okay, and again, we're going to use the base and height instead of length and width. It's more universal. Okay, so now if we look at a parallelogram, right, here we go. How do we get the area? And here's how, is we're going to take the height. Notice that the height is not a side length. This is the height. And it's the same formula. A parallelogram, the area is in fact base times height. And the reason why is if I take this triangle and cut it off, I can put it right here and it's going to match up, and we're going to have a rectangle. Okay, but the important thing here is that this is the height, right? So it's not a side length. Okay. A rhombus is a special parallelogram. You can always, apologize for my drawings, use base times height as well. However, a rhombus actually has this kind of special cool deal. So if we draw in our diagonals, we know from our properties these are right angles, and these four triangles are congruent. And we also know that the diagonals bisect each other, right? So the area of one of those right triangles is 1/2 of a diagonal times 1/2 of the other diagonal. Notice that I'm calling this diagonal 1 and diagonal 2. It doesn't matter which one's which. Okay, but that's, if I multiply that by half, that's the area of one triangle, right? Like, say, just this one. And I have 4 of them. So I have this kind of crazy thing, 4 times a half to diagonal 1 times a half of diagonal 2. When you simplify this, and this is something you should make sure you understand, you end up with 1/2 of diagonal 1 times diagonal 2. Okay? So this is for a rhombus. It's just another way to do it. Again, a rhombus is just a parallelogram. So if you had the height and the base, it's also base times height. Okay, so this is also true. This is just a special version, which will also work for a square, right? Because a square is a rhombus. Okay, the last shape we have is a trapezoid. And a trapezoid here, if you notice, it has 2 bases, and it also has, this height, right? Height's perpendicular. And so the formula that you need to know for a trapezoid is the average of the bases, so you add them up and divide by 2, times the height. Okay? Sometimes that's shown as height times the sum of the bases over 2, right? These are all equal. And one way to think about how that works is kind of like a parallelogram. If you just imagine, we could take this triangle, cut it off, and put it here and make a rectangle. And if you notice, the base here of the rectangle, in fact, I'm going to put that in blue. So here's the rectangle, right? The base of the rectangle is shorter than base 2, but longer than base 1. It's the average of the 2 bases. So it's really the average of the bases times the height. Okay, so make sure you understand, or at least you know all of the formulas for the areas of a quadrilateral, and it would be really helpful if you knew where they came from.